In this problem, we have the great pumpkin, which I drew. It's not so great. It is rising from the ground away from Charlie Brown and Linus, and we know that the great pumpkin is 80 feet away from them. So since that distance is constant and doesn't change, I'm going to label it with 80 feet. However, I am going to label the height of the great pumpkin with a Y, since the great pumpkin is rising off the ground, so that distance is constantly changing. We're also given that the angle of elevation is changing at a rate of pi over 36 per second. So to draw the angle of elevation, I'm just going to start from Linus's toes up to the great pumpkin, and then that color's a little hard to see. Maybe we can make it a little darker. And then that angle is theta. So we're given that d theta dt, because that is the rate that the angle is changing, is pi over 36. And that would be in radians per second. And we want to know how fast is the altitude of the great pumpkin changing when the great pumpkin is 6 feet off the ground. So since y represents the altitude of the great pumpkin, we want to first solve for dy dt when the great pumpkin is 6 feet off the ground, so when y equals 6. So in order to solve for dy dt, we're going to need an equation to help us take the derivative of, and since we need to incorporate y into our equation, I'm going to use that tan theta equals the opposite side over the adjacent side. So tan theta would equal y over 80. So tan theta equals y over 80. We could also think about that as 1 over 80y. And so now I'm going to take the derivative of that equation to get secant squared theta d theta dt equals 1 over 80 dy dt. And since I am solving for dy dt, I'm going to multiply by 80 to the other side. So I have 80 times the secant squared of theta d theta dt equals dy dt. And I know that d theta dt equals pi over 36, so I'm going to have 80 pi over 36 secant squared theta equals dy dt. So we still need to know what dy dt is when y equals 6. The problem is there's nowhere to plug 6 in because we don't have a y in our equation. However, we can solve for theta when y equals 6, and then we can plug that in. So if I create a little, well, we don't need to create a triangle. We already have an equation to help us solve that. So we can say that tan theta equals 60 over 80. And then I can just take the inverse tangent of that. So theta equals 0.07486. And then we're going to substitute that in for theta. So I'm going to send secant squared theta to the bottom and have it be a cosine instead. Easier to put into the calculator. So that's 80 pi over 36 times the cosine of my answer squared so dy dt equals 7.021 feet per second. In part B, we want to figure out how fast is the distance from Charlie Brown and Linus to the Great Pumpkin changing when the Great Pumpkin is 6 feet off the ground. So in order to do that, we need to find a different rate. We need to find the rate between, which I'm going to label R. So we need to solve for dr dt. So in order to do that, we're going to need to create a different trig equation. Or actually, we can just solve for r when y equals 6, and then we can find theta, and we still will need to solve for dr dt. So in this case, since we want to solve for dr dt, we're going to need an equation with an r in it. So we can use that the cosine of theta equals 80 over r. Or I can say that 1 over 80 cosine theta equals r to the -1. And this should be a little bit easier to take the derivative of. So the derivative of the first side of the equation would be 1 over 80, or -1 over 80, sine theta equals -r to the -2 dr dt. And since we're solving for dr dt, we want to divide by the -r to the -2. So we have the negatives will cancel out. So we have 1 over 80 sine theta divided by r to the -2. And since that r to the -2 is on the bottom, I can move him to the top. So I have 1 over 80 r squared sine theta equals dr dt. And so now when y is 6, we first need to solve for r, and then we already know theta from the previous problem, so we can plug that in. So r is going to be the square root of 6 squared plus 80 squared. R equals 80.225. So now I know that dr dt is going to be 1 over 80 times 80.225 squared times the sine of theta, which is 0.07486. So now we're going to type all that into our calculator, which equals 6.017 feet per second. For part C, we're asked if Charlie Brown and Linus can run at a rate of 20 feet per second. Can they catch the Great Pumpkin before it gets out of their reach of 6 feet? So we know that Charlie Brown and Linus are 80 feet away from the pumpkin. So if they run at 20 feet per second, they can get to the Great Pumpkin in 4 seconds. However, from part A, we know that the Great Pumpkin rises at a rate of 7.02 feet per second. So if we multiply 7.02 times 4, it's definitely going to be out of their reach of 6 feet. it will be all the way up at 28.084 feet by the time that they get there. So explaining your answer to part D, kind of already done that. The pumpkin will be at 28.084 feet before Charlie Brown and Linus will be able to get there.